In here, we're going to look at applying transformations to logs. So first, we're going to start with just doing regular transformations. We are going to then also look at the issue of doing an inverse transformation. So that would involve converting a log to an exponent to a log, or vice versa. Okay, those are inverses. So when we apply an inverse, we're going from one to the other. Okay. The references that we're going to use again for the exponent, we're going to use the y-intercept and the horizontal asymptote. For the log, we'll use the x-intercept and the vertical asymptote. Okay, and if we do an inverse, they just switch as well. Okay, so if I take a look at this transformation here, I can see that there's a transformation on the x. There's a transformation on the y. I'm going to just start with the y. The change in y is just going to be one transformation. It's a vertical expansion by 5. Okay, the change in x is in green. Now I'm getting used to doing this as factored form, so I'm going to rewrite this in factored form. I get y equals 5 bracket 2 bracket 3 x minus 2. So the factored form then allows me to do the compression first, shift last. Okay, that's the idea behind using a factored form. So I'm going to do a horizontal compression by 3. Okay, second step is a horizontal shift. It's going to be plus 2 to the right. Okay, so there's my transformation. Okay, so how can we apply some log and exponent properties when we do transformations? Well, to do any transformations, we have to remember that it's got to look the same. We need to have the exponent inside change and something on the outside change. Well, this one here, the base changed. Well, I can't have different bases and then be able to describe a transformation because I don't know what a base change is unless I can somehow relate the base change to each other. So in this case here, this base 2 and base 1/4 in fact are related bases. And I can rewrite 1/4 as 2 to the negative 2 power. Well, now I have the base is the same, and I can now kind of group the transformation part of it together. Now there's nothing on the outside, but the transformation, there is a transformation on the inside. So I get 2 power to power, and I'm just going to leave it in factored form. It's going to look like that. Okay, so if I have exponential growth, 2 to the x looks like that. Okay, that's actually exponential decay. When I multiply by a fraction, I get exponential decay. That's a horizontal flip. And in fact, notice that the negative power, which gave me the 1/4, gives me a horizontal flip. So this now can be described with our transformation because I can see the transformation pieces now once I've algebraically rearranged it. My transformation is only in the x's. And the first thing is going to be a horizontal flip. It went from exponential growth to exponential decay. I did a horizontal compression by 1/2. Okay, and then I'm going to I'm just going to move it horizontally. It's a horizontal shift to the right 1. Okay, so to be able to apply this in this case, though, I have to be able to express them with the same base, which means I need to use some exponent properties. Here I have an exponent to a log. Well, I've got to do an inverse. Now, inverses can be done at any point in time, but it's probably easiest to do it at the very beginning or the very end. In this case here, it's probably good to be able to write it as a log form first. Okay? So my first step is going to be my inverse. I'm going to do this in blue. So my first transformation is inverse. Okay, which is I'm going to make the x into y's and y's into x. So I'm just going to rewrite it like this at first. There's my inverse. Okay, which means this is log base 2 of x equals y. Okay, there's now my inverse. And maybe I'll write the y on this side. Okay, now I can see my transformations on the inside and outside. Okay, so my transformation on the outside are going to be those. That's my changes in y. So my change in y, the first step in the change in y is going to be vertical expansion by 2, vertical shift up 1. And then my horizontal, my change in x, is only one transformation. It's a horizontal shift to the right 3. So in order to be able to describe a transformation, I have to first of all recognize it's an inverse. I have to apply the inverse, and then I can then see my transformation much better. So here I have this horizontal transformation and vertical transformation. Okay, so I'm just going to do this. I'm going to factor it, okay, because I like the factored form. Okay, so there's my factored form, and I can then see that I have, well, this is pretty much all horizontal. Actually, I do have a vertical, so I'm just going to start with my vertical. So the only thing that happened was a vertical shift down 1. Okay, and then I'm going to look at my horizontal, my change in x is my horizontal shift, horizontal compression by 2. That's a compression first. It's always factored form is always compression first, and then secondly it's going to be a horizontal shift plus 2. Okay, so there it is. I have a horizontal shift and horizontal compression, then a horizontal shift. For this one here, I have a change of base. Well, that's a bit of a problem. I cannot describe this with a change if the bases are different. So I have to convert this to the same base first. Okay, I can see there's some kind of horizontal change there, so I'm going to change this to base 2. Base 2 log of the argument divided by log of the base. Okay, that then allows me to express it in terms of my base 2 log, which then allows me to rewrite this. Log base 2 of 4 is 2, so I get to divide by 2, and then I get 8x here. Okay, so this is a nicely separated out now. I have my outside transformation, I've got my inside transformation. So my outside, so my change in y is going to be a vertical compression by 1/2, and then my inside, that 8, is going to be a horizontal compression by 1/8. Okay, so those are the transformations on my graph.